Yeah, kids are awful.
I'm just joking with you.
It's okay.
It's really your kids.
Yeah, they're spectacular for the most part. They're busy. We can't wait for daycares to open. That would be spectacular. But okay, where was I going? I'll do this. Uh, I think there may be an assignment due sometime soon. Technically, maybe.
Isn't there one for the garden?
I don't know. I just it tells me. I mean, if it's passed in late, I whatever. It's as long as it's done. Naming everything assignment.
Did you get one?
Who? Amy? Yeah, I started going through it, but then it's like, oh, Kate needs to be changed and go down for a nap, and Ben needs to be dealt with. So, yeah, apparently that's, but whether it's turned in now or later or whatnot, Gesundheit is not, she's got COVID. Stay away from her. That's the sneeze. Um, um, so, oh, 9 sorts today. Um, where was I going? Oh, well, that's not page 34. Uh, yes, Tuesday, because today is Thursday. We started reactions. Um, reactants to products. We talked about, or maybe we did this on Monday, and then Tuesday we continued with balancing. That one there isn't going to balance because it's an oxidation reaction, and iron is +2 here and +3 here, and there's nothing else that changes charge. Um, so that's why that fundamentally is not able to balance. If it was, I'd have to change different things. And then we talked about balancing in general. Um, write the formulas, which you're normally going to be given for all the reactants. Count things on both sides. Balance elements one at a time by adding coefficients. I did some different examples. Hydrogen and oxygen going to water, burning methane, a single replacement with silver nitrate with copper, aluminum and nitrogen, where we had a 2 and a 3, odd and even. We want to make it common. Uh, phosphorus, and we did those. The trick, if you have an odd number like 2 and 13, an even number like 2 and an odd number like 13, you double everything. Well, doubling that 13 is going to give you an even number, so then you can go through. Um, and I went through after and balanced all of those. Anything that doesn't have a number in it is 1. I had to double number 8 when I balanced the iron and the um, sulfur. I think everything else. Is there any questions with any of those ones? And then the one that was probably the most tricky was number 8, because you have 4 oxygens and a whole bunch of 4 phosphorus and a whole bunch of those. Um, 2, I had to double something at one point, but this is Just my thought process, because I've bounced equations long enough that I don't count anything per se. Um, H C L O B 1 1 14 and 4 3 2. Oh, that's going to be the doozy. 4 and that's 11 and 1. So if I'm looking at one like this, because it's got bigger numbers, it might seem intimidating. You can really start anywhere. The one that I would start last always is oxygen, because it's in 4 spots. If I can balance everything else and the equation is written properly, we hope that oxygen just kind of falls into place. So if I'm looking at this one, um, I've got 1 hydrogen here and 3 hydrogens here. I can start by putting a 3 there, but then when I kind of bounce back and forth, if I put a 3 here, that means I've got, and this could work, and whatever, however many oxygen, 12, 22. 3 chlorines and 2 chlorines. Well, that sucks. So then I've got to deal with other things. Some of balancing is trial and error and practice. Looking at this, I've got 3 and 1. I've got 2 and 1. So if I can get these two to work out, then it should be a little bit easier there. I would start with phosphorus myself, because if I put a 2 to balance the chlorine, the hydrogen isn't. If I put a balance the phosphorus, it's a little bit, it's not automatically doing, well, it's doing a couple of things, but 4 of those, so well, that was supposed to be a 4. 4 of those. So that gives me 3 4s are 12, 4 1s are 4, 16, and 7 is 23. Okay, so now I've got an even number of the only one that was really odd, the oxygen, I don't care about yet. So if I have 12 hydrogens, my next step is to go over to here and say, well, if I need 12 hydrogens, I got to put a 12 there. So that becomes 12. Oh dear. That becomes 12. 48 and 10 are 58. Big numbers, but whatever. Phosphorus is still balanced. Hydrogen's balanced. 12 and 2, I see, well, that's easy to balance. I put a 6 there. That gives me 6. And also 6 and 7 gives me an even number of oxygens. So now I hope when I count every oxygen on that side, I don't know why I wrote a 6 there. That should be 12. Now we count, cross our fingers and hope. So 4 times 4 is 16. 6 times 7 is 42. Let's do the math right. 40, 50, 56, 58, and that one works out fairly nicely. Even though the numbers are big, why we can't just divide everything? Well, that's a 1, so 12, 1, 4, 6. I'm just trying to think what I want to, we're going to talk about equations, maybe today or tomorrow. So are there any ones, I don't recall hitting the save button, on either of those 2 pages that anyone has any questions on? Hopefully you all got them all correct. That would be awesome. Um, there is another page of those. I will balance these ones uh, this afternoon, I hope. Some of them may take a little bit of time. That one's balanced. There's a nifty one that's balanced as it is. Two of those, three of those, six, no. But the strategy, how I go about them, as I look at this, hydrogen's an element on its own. Hydrogen's an element on its own. Leave the elements. Well, when I have an element in something, this gives me 3 magnesium and 2 phosphate. 2 phosphate, 3 magnesium. Now let's hope. 2 times 3 is 6. 3 times 2 is 6. Those are good. 2 nitrates, 1 nitrate. I'm going to put a 2 there. That means I need a 2 there. And that one's done. 2 nitrates, 2 nitrates. That's always a fun type of question to give on a test. Here's an equation. Balance it. If you count everything correctly, it's actually balanced to start. Nitrate, there's 2 and there's 3. Let's make them 6. The nitrates are balanced. 6 aluminum, 3 lead, 3 lead. Now that makes little sense. Because those are all, because that's not a 6. That's a 2. That makes much more sense. So, I mean, I can go through and balance all of these fairly quickly. Well, I've got 3s and 2s. 2 and 2. And so on. I don't think we need to spend time doing all of those. I mean, 12 of them took a couple minutes, so they'll be in your notes. I know I'm going to run into something down here that's problematic. So because I'd already filled in part of this file and I hadn't gone through, if you look in here, "11 types of chemical reaction notes." This is part 2. Starts here. Types of reactions. There's 5 types of reactions that you're technically responsible to be able to identify. And they are kind of fair. I think they're easy to identify. Technically, we're supposed to predict products. We'll talk about that in the end. The key thing is we recognize them by the left side of the arrow. So what you start with tells you what type of reactions with. So the first one is a combination reaction. Sometimes you'll see these referred to as formation or synthesis. Combination, combine, form. You're forming something. 2 elements, or sometimes 2 compounds, but you have 2 things going to 1. most of the time, if I'm asking you to predict products, if there's two elements, you go on further in chemistry, you can see that sulfur trioxide and water, that's how they actually make sulfuric acid. But it's based on, and this is a little bit of predicting products. A lot of these are ionic. If it's molecular, you have to have some guidance because how they combine is a little bit crazy. So we know if I take, whoops, calcium, I know that makes +2 ions. I know that chlorides are -1. So +2 and -1 means I need CaCl2. An element plus an element gives a single compound. Is a formation or synthesis or whatever, or combination reaction. This says iron 2 oxide, so we know this is +2. We know oxide is always -1. So the arrow here is Fe2 plus and O. The equation isn't technically balanced because I've got 2 oxygens there, so I'll put a 2 here and a 2 there, and now it's balanced. Aluminum is +3. The oxide is -2, and that's Al2O3. 2 and 3 means I need a 3 and a 2 and a 4, and that was one of those things. First step is to write, if I give you a question on an assignment, predict the products of this formation reaction. Well, it's going to be a metal and a nonmetal. Put them together with the right charges, which is the same thing that we've done multiple times. So formation, we can combine two compounds. Carbon dioxide and water makes what's called not H2CO2 but H2CO3, carbonic acid. This one is 2HClO4s, perchloric acid. Those are things that you're generally just going to take them. There's not a whole lot of balancing to them. Um, I mean, that one had to be balanced. But these are technically combination reactions. So if you get two things making one product, normally it's two elements going to one product or compound. Um, though that is a synthesis or formation or one of those reactions. If we were doing this in class and doing it over a while, I use the terms interchangeably because I kind of forget from 1 minute to the next. Uh, decomposition reaction are things that fall apart. If you take salt and melt it and get molten sodium hydroxide, you pass a current through it, you actually get chlorine gas and sodium. Calcium carbonate, um, you heat it up enough, eventually you get carbon dioxide off. Um, but the key thing here is one reactant falls apart. So you're going to have some sort of compound going to. So decomposition reactions are the easiest ones to identify because there's one reactant. You take something and you break it up, whether it's in 2, 3, 4 different things. If it's a binary compound or made up of two elements, usually it falls apart into an element. We have a set of apparatus at school. I, for the life of me at the moment, can't remember what it's called, but it's basically splitting water into its elements. You take two electrodes, you put water in it, and if you get, depending on whether you have the anode or cathode, H2 and O2, two oxygens, two oxygens, and you can do that, and it's a nifty little thing. Mrs. Parley does it a lot I've never actually used the thing, and I don't want to break it. So this one is one of the oldest decomposition reactions. The ore of mercury is mercury 2 oxide. It's a rock or it's in a rock. I can't remember if it's cinnabar or something like that. But years ago, someone decided, well, they were heating rocks for Lord knows what reason, and out comes a weird liquid metal and some bubbles. Well, the bubbles are oxygen, two oxygens, and that's how mercury was discovered thousands of years ago. But it's just an element, one thing going to two compounds or two different things. It can be technically you could have some things decompose into multiple things. Um, it's not as common. Normally, it's just something falling apart. Over there, I had the carbonic acid. That particular thing, H2CO3, actually in like you can never have a bottle of that sitting open on a desk because this is inherently less stable. Well, if I take H2 and O, well, what's left if I take that out and one of those? Well, carbonic acid to keep, you basically have to have it under pressure. Well, carbon dioxide and water. Anybody have a soda stream machine at home? I've got one upstairs. Or a bottle of pop. Any carbonated beverage, you're just adding carbon dioxide to water. Technically, in your bottle, you're making carbonic acid. You open the lid and the bubbles start to come up because carbon dioxide is coming out of solution and any carbonic acid is actually falling apart. It's really just dissolving carbon dioxide in water. 6 minutes. I hate that thing. So anyway, I'll do single replacement and then quit. Single replacement is like, well, it doesn't happen anymore because school dances don't really exist, but it's like cutting in at a dance. Potassium and chlorine are dancing up a storm. They're having a great time. And then sodium comes in and says, hey, taps potassium on the shoulder, boom, pushes potassium out of the way, and then they start dancing. One element and a compound. Products are a different element and a different compound. It has to do with charges. Sodium's a metal. It's going to bump this out. Those two are going to trade places. So we get potassium and salt. You can do it with nonmetals. Really, the only nonmetals are the halogens. Fluorine comes and bumps fluorine out. You get lithium fluoride. You can metals replace metals is kind of the big thing. Aluminum plus copper sulfate goes to aluminum, which, well, now we have to think this is +3. Right now that's minus or +2 because that's -2. So aluminum sulfate plus copper, um, a 3, 2, and a 3. Zinc hydrogen can be bumped out depending on this silly activity series. You get zinc sulfate and hydrogen gas because hydrogen in this sense is a +1. Zinc makes +2. They switch. There's this thing called the activity series of metals. The first time I ever heard of it was teaching because it's like, okay, you eventually, I'm sure it's some book, technically it's an electrochemical series, which takes a whole bunch of other things. Lithium, if you have lithium plus any other thing, will bump anything out. Potassium will bump anything but lithium. Calcium bumps anything but lithium and potassium. Sodium will do everything but those three. Magnesium will do those plus this one. Hydrogen, this is in an acid. Everything, all of these things will react with an acid. Those three, copper compounds, mercury, and silver don't. Um, water has an H. Technically, this is +1, -1. Water, this happens. You throw sodium in water, it bubbles and fizzes and does all sorts of crazy things and whatnot. So normally when I talk about something like this, reacting a metal with water, I have that blue H and the red OH. So if we think about this in terms of charges, sodium right now is neutral, but it's going to be +1. Hydrogen on its own is +1. The OH is -1. So what's the sodium going to bump out? It's going to knock that blue hydrogen out on its own. It's going to say, get out of the way. So sodium is going to make a compound. Sorry. Sodium, and it's got that OH sitting there. Hydrogen doesn't like to be on its own. So because it's hydrogen, it's a diatomic molecule. The OH sits there on its own. Technically, I need a 2, and a 2 to balance it. But that's what happens. Water, we talked about, basically we're splitting it right there, making plus and minus, because we can rip that apart and do that. Sodium is higher than hydrogen on an acid or water. Only the first couple. Aluminum doesn't react with water. How do I know aluminum doesn't react with water? Has anybody ever gotten aluminum foil wet? Uh, if aluminum reacted with water, it would cause all sorts of problems because, well, you put something warm and you cover it with aluminum foil, well, and you get moisture coming from steam. If it reacted with water, you would start to have this big reaction there. Magnesium doesn't for the most part. Those ones will react. Metals from lithium to sodium will replace acids and water. Some people make people memorize this. I just want you to know that it exists. Like the question over here, note the star, will this reaction happen? Is aluminum above hydrogen? Yep. Is iron above copper? Yep. Is lead above potassium? This one actually will not happen. Aluminum is not one of those first four. So this one will go. You'll get Al, Cl3 plus H2. I need 6 of those, 3 of those, 2 of those, and 2 of those. This one happens. This is one that we do at school because I can take a solution of copper sulfate, give iron sulfate, and a copper metal, or I think technically actually we do the reverse. Those two don't happen. Silver is on the bottom of the list. If you have a compound with silver, everything will knock silver out. Silver is, ironically, silver is a nice pretty metal, but it's the one that no anion really wants to go with. We can do the same thing with nonmetals. Fluorine bumps these, chlorine bumps those, bromine will bump that. So fluorine will actually bump chlorine, but bromine Actually, we'll do. Shoot. Do, 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 do. Sorry, the joy of I'm always in a rush because it's like I don't want to take up all your time. I want you to be able to. I don't even know if it's sunny out. Okay, heck with that. No. Reaction. Our accent is short for reaction. So tomorrow we'll talk about double replacement and then this. If you do any homework or practice tonight, I would go back to these ones, finishing those. The more you do balancing, but if you look in here, in the second one, well, we're going to talk about double replacement. Identify it and balance it. Identify it and balance it. Combustion, predicting products. We'll do a little bit of that. I write a balance. We may do it. Just we have to do. I hate net ionic equations, but that's just a personal thing. I'll have to go and figure out exactly what we're gonna do. You're gonna have to do those ones. Whoa, that went way further than I thought. Eventually, um, but yeah, that's kind of where I wanted to stop today. Does anyone have any questions? Did we pick up? Oh, we lost a bunch. We had like 13 here. You guys are the only ones who wanted to put up with me. Any questions, or are we all happy? Awesome. Oh, I keep seeing that. It's like I sit way back in the screen still that you can't see my face. Maybe I'll have to start sitting like this. So, have a good afternoon. Enjoy the, I think it's nice-ish, and we'll see everybody tomorrow.